of each element. For iron, we have 2, and I know that because the subscript is 2. So the subscript only applies to the element that's right in front of it. So 2 irons. Oxygen, I have 3 because there's a 3 as a subscript. Carbon, I only have 1 because you know when there's no subscript, it means 1. On the other side, iron, it looks like we have 1. Carbon, we have 1, not 2. The 2 only applies to the element that's directly in front of it, and that's going to be the oxygen. We have 2 oxygens. Okay, now typically you'll find that there are like little, like if you do a homework assignment, you'll find that there are little blanks in front of each compound, and that's for a number. When you're balancing chemical equations, the only thing you can do is add molecule numbers in front of the molecule. And molecule numbers are kind of similar to coefficients in math. So for example, if you have a term x, y in math, and you add 4, put 4 in front of it, that means that everything in that term is multiplied by 4. Okay? Well, it's the same idea with chemical equations. If we put a number in front of a formula, that means that everything in that formula is multiplied by that number. Okay? So let's try this out. When I look at this, I see that the iron and the oxygen are out of balance. Okay? Carbon is okay for now, but that, that may change and we may have to balance that out later. All right, I'm going to start really simple since this is our first go at this, and then we'll move to some that are more complex later. All right, so I have 2 irons on the left side and then 1 on the right. So I'm going to start by multiplying the iron on this side by 2 because my goal is to make the numbers be the same. And so the lowest common multiple is 2, so I'm going to try to make both sides 2. And I can do that by multiplying the iron by 2. So I go into the equation, find iron, it's right here. I put a 2 in front. Remember, it's just like a coefficient. Everything in this formula gets multiplied by 2. So now I have 2 irons. This may change later. As I start to go back and forth, I may find that I need to raise this, and that's okay. But I'm going to start with 2. Okay, so this is good. Now I'm going to come back to this side. All right. Actually, you know what? I'm going to stay over here because this number is lower. Okay, I see 2 oxygens here and I see 3 there. A common multiple is 6. So let's see what happens if I try to make both sides 6. I'm going to start by multiplying the oxygen over here by 3. So I'm going to put a 3 here. Okay, that means that everything in this formula is going to get multiplied by 3. So I now have 3 carbons. And I actually have 6 oxygens now on that side because there are 2 oxygens originally. 2 times this 3 gives us 6. Okay? Now let's come back to this side. All right? So iron's looking good right now. Oxygen, okay, I see a 3 and a 6. I can work with that. Carbon, I see a 1 and a 3. We can work with that also. Okay? Let's start with the oxygen. Okay? I can multiply the oxygen here by 2 in order to get 6. So I find oxygen in the formula. Well, it happens to be in this formula with iron, and that's okay. I can't put the 2 here. I always have to put it in front. So I got to put it in front of the whole molecule. Okay. So consequently, that's going to change everything in this molecule. I now have 2 times 2, which is 4 irons, and I now have 3 times 2, which is 6 oxygens. Okay, so that works. I am going to have to go back and make an adjustment in iron on the other side, but that's okay. Let's look at our carbons. I have 1 and 3, so I can multiply the carbon here by 3 in order to have it match this carbon. So I'll put a 3 there. Now I have 3 carbons. Okay, and so the only thing left to do is to go back to this side. Okay, I have 4 iron here and I have 2 there. So this, I'm going to change it to a 4. Okay, and so that is my answer. Okay, in order to balance this equation, I put a 2 in front of iron oxide, a 3 in front of carbon, a 4 in front of iron, and a 3 in front of carbon dioxide. Okay, so that's how we would balance that equation. I'm going to go ahead and do a couple of examples from the homework assignment and give you an opportunity to work on that for just a little bit. So I'm going to pause for a minute and let you get the homework assignment, and we'll work on a couple of problems from that page. Okay, so here is the first one from the homework assignment. The homework page is Balancing Chemical Equations, Worksheet 1, and it has 13 equations on it. So we'll work out a few, and then I'll let you kind of go on your own and see how you did, and see how you do. Okay, so the first one is zinc plus oxygen, and that yields zinc oxide. Okay, so the first thing we do, again, is we make an assessment of what elements we have on the left side and on the right side, and the numbers of each of those elements. So I'm going to draw a line here. And when you do this, boys and girls, I want you to show your work. Maybe on a loose leaf sheet of paper. There may not be enough space underneath each problem on the worksheet for you to show your work. So do show your work on another sheet of paper. All right. So on the left side, we have zinc and we have oxygen. Okay. On the right side, looks like we have the same thing. And that makes sense because according to the law of conservation of mass, whatever elements are on the left, you got to have on the right. Okay. Let's look at the number of each. On the left side, I have 1 zinc. Oxygens, there's 2 because the subscript is 2. On the right side, I have 1 zinc, understood subscript of 1, and I have 1 oxygen. Okay. Is this one balanced? If you said no, then you are correct. Okay, so we need to do some work here to balance this one. All right. So zincs are good, but the oxygen is not. Okay, so the lowest common multiple here is 2 between 2 and between the oxygens. There's 2 here and there's 1 here. So I can multiply this oxygen by a number in order to get 2. If you said 2, then that's correct. So we can multiply the oxygen by 2 on this side in order to get 2. So I find oxygen in the formula. It's up here in the equation. It's in this formula. Now, I can't come in the middle here and put a 2 there. Remember, the only thing you can do is add molecule numbers to the front of the molecule. So I got to put the 2 right in front. Okay? So the 2 goes right in front. And consequently, that's going to change everything in that molecule. Zincs now become 2. So 2 times this 1 zinc is 2. So I'm going to change that to 2. Oxygen also becomes 2. 2 times 1 is 2. Okay? Now, that takes care of the oxygen. That looks good. But now the zinc is unbalanced. So I got to come back to this side. Okay? There's 1 zinc on the left and there's 2 zincs on the right. So what could I do in this case? If you said multiply the zinc on this side by 2, then you are correct. So we can come into the equation, find zinc. We put a 2 there. Now the 2 only affects what's in this molecule. It doesn't affect what's over here. So this becomes now 2 zincs. And at this point, it is balanced. So the answer would be to put a 2 in front of zinc and a 2 in front of zinc oxide. Now, let me ask you, is there a molecule number here in front of the oxygen? If you said yes, then you are correct. There is an understood 1 that's there. Okay? So if you don't have to put a molecule number in a space in front of a molecule, you can either leave it blank, or you can put a 1 there. Okay? There is one number, however, that you should never put in any of these blanks, and that number is 0. Because if you put a 0 there, it means 0. All right? Okay, let's try out another. Let's take a look at number 8. Let's take a look at number 8. 8 looks kind of big and scary, but it's really not. So this is barium chloride. I'll just write it out first. All right, hopefully you can see all of that. All right, so this is the equation, and on your sheet, of course, each molecule has a blank in front of it. Okay, let's assess what elements we have. All right, so I'm going to draw my little line there. On this side, we have barium, chlorine, hydrogen, sulfur, and oxygen. Okay, so on the other side, we should have the same elements: barium, chlorine, hydrogen, sulfur, and oxygen. All right. Now, on the left side, how many bariums do you see? I see 1. Chlorine, I see 4. There's 2 here, plus the 2 that's here. So this is 4. Hydrogen, I see 4 also. 2 here and 2 there. Total of 4. Sulfur, I see 1. Not 3. If you said 3, take a look at that again. The 3 only applies to the element that's right in front of it, and that would be the oxygen. Sulfur, there's only 1. Okay? And then oxygen, I see 3 plus this 1, which is going to be 4. On this side, barium, I see 1. Chlorine, I see 1. Hydrogen, there's 1. Sulfur, again, there's 1. The 4 only applies to the element that's in front of it, and that's oxygen. So 4 oxygens. So take a look at that for a second. What would you do if you needed to balance this? As I look at this, I see chlorine and hydrogen. Those are the only ones that are out of balance. What could you do? If you said you would multiply chlorine and hydrogen by 4, then that is correct. Because when you look in the equation, they're right here together. And and 1 is a factor of 4, okay, for both of these. So I could put a 4 right here. Okay, now it's going to change everything in this formula, but I think that's okay. So 4 times this 1 hydrogen will give us 4 hydrogens. 4 times this 1 chlorine will give us 4 chlorines. And if you look, it's balanced. So what would go in these other blanks? So remember, there was a blank. There's a blank here. There's a blank there, there, and there. Okay? We could put 1s in those blanks, or just leave them blank. If you wanted to put 1s in, you could do that. Or just leave them blank. The only thing you can't do is put a 0 there. Okay? So boys